Okay, so now we know how to calculate the length of one side if we have two other sides. What about if we don't have two other sides? What about if we only have one side and an angle? Well, first let's draw a nice big triangle up here to remind ourselves what the sides are called. So we've got the opposite, the adjacent, and the hypotenuse. Okay, and then we've got our angle, remember, in here, which we can call theta. Lovely Greek symbol, theta. So remember the opposite is the opposite because it's opposite our angle. So, what do we do if we only have one side and the angle? How do we work out the other sides then? Well, we have to use these trigonometric functions. Now that sounds horrendously complicated. It's not, it's relatively easy. I don't know if you've ever heard of this. That could possibly look like utter gibberish to you. Basically that is SOHCAHTOA. So remember SOHCAHTOA. So basically SOHCAHTOA. That is how we remember our trigonometric functions. We've got our first one, which is sine. So sine theta, and our angle. So basically we do something, we do our sine function to our angle, and that will equal the O, the opposite, divided by the H, hypotenuse. Okay, we've got K now, so that is cosine, or cos, of the angle, and that will equal the adjacent divided by the hypotenuse. Okay, and then we've got the last one, which is tan of our angle, which will equal the opposite over the adjacent. So, sine theta is opposite divided by hypotenuse, cosine theta is adjacent divided by hypotenuse, and tan theta is our opposite divided by our adjacent. Learn them. Learn SOHCAHTOA. Learn these. You need to know these off by heart. You won't be given these in your exam. They're not hard to remember. Make sure you remember them. Basically, when you're doing the practice questions, you'll get to know them because you'll be writing them down over and over again. So, it's up to you to remember them now. I will leave this picture at the top and I will write SOHCAHTOA in the top just so we can remember. Again, as with all these things, do not be afraid to write SOHCAHTOA down in your exam on the paper. If you need to write it down to remember it, write it down. The examinator, the guy marking it, is not going to go, this guy writes SOHCAHTOA in the top. He's not going to care. As long as you get that right answer, that's what matters. So do what you need to do. Do your number line, do your SOHCAHTOA, do whatever you need to write down to get you to remember it. Okay? So, let's look at an example. So, here's our lovely triangle. Okay. We are told that this angle here is 30 degrees. Okay? And we know what this side is. This side is 12 centimetres. What on earth does the adjacent equal? What on earth does it equal? Well, first, let's see what function we're going to need to use. We've got the opposite, we've got the adjacent, we've got an angle. Which starts so, opposite, no, hypotenuse. No, that doesn't have an, it's tan. Okay, TOA, we've got opposite and adjacent, the only one with it in. So we need tan theta equals opposite over adjacent. Now let's put those numbers in. So, tan of the angle 30 equals the opposite 12 divided by the adjacent. Okay? So what is tan 30? Let's pick up our calculators. There will be a button on your calculator that says tan on it. Press tan, then type in 30 and press equals. That will tell you what tan 30 is. So tan 30 in this case is 0.577. So we know that 0.577 equals 12 divided by A. So we need to make A the subject. So what do we need to do? We need to get A up off the bottom. So we need to times both sides by A. That will get rid of our A. So we get A times by 0.577 equals 12. Now we need to divide both sides by 0.577 to get it off here. So we find that A equals 12 divided by 0.577. So 12 divided by 0.577 gives us our answer, which is 20.8. Never bother writing anything to more than 2 decimal places. If in my question I just got a 12 and a 30, writing something to more than 2 decimal places would just look silly. So I generally try and stick with 1, and it generally works. So also, if you've got units in there, quote your units at the end. So if it's centimetres, make sure it's centimetres at the end. So we know that that would be 20.8 centimetres. Okay, let's look at some other questions. Okay, so let's look at some other questions. So again, we've got a triangle. Now, in this question, we are told that we know the hypotenuse is 15 centimetres, and we're told we know the angle is 42 degrees. Okay, so what do we need to use? That's what we need to think. So, what are we being told to find? In this case, we're being told to find the opposite. Okay, so let's have a look. We've got the opposite and the hypotenuse. It's sine. We can see that straight away. It's the first one we come to. So we know that sine of the angle equals the opposite divided by the hypotenuse. Okay, so let's put those numbers in. Now, it's up to you which way around you do it. You can put the numbers in first and then rearrange, or rearrange and then put the numbers in, but it's up to you basically. So in this case, we've got sine theta. So sine of 42 equals O, which we're trying to find, divided by 15. So let's put that that's op, because otherwise it looks like a 0. So let's do sine 42. So let's do sine 42. Again, find the sine button on your calculator. 42 is 0.669 equals the opposite divided by 15. Okay, so slightly easier than the last one. Let's use our algebra. All we need to do is times both sides by 15 this time, don't we? Because we've already got the opposite is already on the top. Okay? This is why you need to be comfortable with algebra, because these sorts of questions, you use it all over the place. So 15 times by 0.669 will give us the opposite, and it is 10. Yeah, it's just 10. So again, if we were given units to start with, we put it in so that we find that this side is 10 centimetres. Okay, all well and good, you may be saying, but what sort of practical use is this for me? Well, the next question will show us a highly practical use for this, which I'm sure all of you will use in your day-to-day life. Or maybe not. You're in a boat. You're out to sea. Here you are. Right, I'm a mathematician and a scientist. I'm not an artist. Here is our boat. That's the same. Okay, there's me. Woohoo! Having fun on my boat. But hang on. This lovely calm flat sea ends in a gigantic cliff. Ah! Now I know that there's a big fat rock somewhere underneath the sea that I'm going to hit. And I know that that rock is a certain distance. I know that rock is 5 meters away from the edge of the cliff. So I don't know if I'm just about to hit that rock, if that rock's ages away, or whatever. How on earth am I going to know how far away I am from that rock? Well, luckily, I've got a bearing instrument with me, and I can measure an angle. So what I do is I look to the top of this cliff, from where I am, which we can assume to be the bottom of the sea, the level of the sea. I look up to the top of the cliff, and I can see that that gives me an angle on my instrument, and it tells me that that angle is 22 degrees. Now, I know the height of the cliff, luckily, because it's somewhere near where I live, and I happen to know the height of the cliff. I know that the height of the cliff is 224 meters. Now, how far away am I from the cliff? I imagine I'm going to be well within my distance, but how far away am I? So, all we've got, let's look, we've got a right angle triangle, haven't we? There's our right angle, there's our theta, and there is our opposite. So, I need to work out the bottom one, so I need to work out the adjacent, so I'm going to use my tan again. So I need just tan of theta equals the opposite over the adjacent, which I don't know. Okay, and hopefully you can sort of see that actually when I've got an angle, a number on the bottom and the tan theta on the top, I need to work out this. What I end up doing through all my algebra is just sort of swapping these two over. Now make sure you understand the algebra of rearranging it, but really you're just swapping these over so that A just equals 224 divided by tan of 22 in this case. And then you can just plug that all straight in your calculator. You can literally just write 224 divided by tan 22, and bang, we've got the answer. I'm actually 554 meters away from the edge. I've got loads of time before I'm going to bump into that rock. I've got another almost 550 meters to go till I bump into that rock. But also I know I'm 554 meters away, so if I really needed to get to here, then I'd be able to know how long it would take me to get back. Also, if I knew there was a cracking fishing spot about 700 meters away from the cliff, I'd know I still had to sail out a bit further before I got to that prime fishing. So there's your amazingly useful real life application.